So this is question 2 from the 2015 sample questions on inferential statistics. And the question reads, the principal of a large school claims that the average distance from a student's home to the school is 3.5 kilometers. In order to test this claim, a sample of 60 students from the school was randomly selected. The students were asked how far from the school they lived. The mean distance from these students' homes to the school is 3.7 kilometers, with a standard deviation of half a kilometer. Part A says test the principal's claim using a 5% level of significance. And you clearly state your null hypothesis, your alternative hypothesis, and your conclusion. Okay, well, let's start by stating our null hypothesis, which will be H0. So the null hypothesis is always that there is no change. So the null hypothesis in this case would be that the mean of the distances from the student's home to the school is 3.5 kilometers. So the mean of the distances from the students' homes to the school is 3.5 kilometers. So our alternative hypothesis then would be that the mean of the distances is not 3.5 kilometers, or that it's different. So the mean of the distances from the students' homes to the school is not 3.5 kilometers. Okay, so we've stated our null hypothesis and our alternative hypothesis. So if we are testing, doing a hypothesis test at the 5% level of significance, which we know here, the 5% level of significance, we are trying to find the Z values, and we're trying to show we reject the hypothesis if the Z value is less than minus 1.96, or if the Z value is greater than 1.96. So if we get that, we reject. These figures here are, that's 1.96. The 1.96 figure is linked to the 5% level of significance, that figure. Okay, so what we're going to do is find the Z value. So the formula for our Z value is the sample mean minus the population mean all over sigma over root n. So that's the sample mean, this is the population mean, sigma is the standard deviation for the population, and n is the sample size. So we can plug these values in. So we're going to get the sample mean, which is 3.7. So the 60 sample students had a mean of 3.7, so that's the sample mean. From that we're going to subtract the population mean, which the principal is claiming is 3.5, so this is what we're testing. And then this is all going to be divided by the standard deviation. Now, we're not given the standard deviation of the population, but we know that the standard deviation of the 60 students is 0.5, so we can use that as an approximation. And this is all going to be divided by the square root of the sample size n. So the sample size n, in this case, is 60. So we're going to put all of that into the calculator, all of this here, and when we do that, we find that we get a value of 3.1, and that's to 1 decimal place. That's sufficient for us to tell if it's smaller than this value or less than this. So because it is, we can say that 3.1 is greater than 1.96. Because of that, we can reject the null hypothesis. So that's our conclusion. So we've done our null hypothesis, our alternative hypothesis, and our conclusion, which we got from our Z score calculation. And that's the end of part A.